Alright, hello chemistry class. This video is going to help you get through today's experiment, which is entitled Families of Elements, as you can see here. So if you would, we're going to actually kind of write a pseudo lab report. It's not going to be a complete lab report, but in your notebook I want you to write down a few components of a decent lab report. So if you would, please first on a piece of paper in your lab book, you're going to take a picture of this lab report and upload it into Google Classroom. So if you would, in your lab book, just write experiment families of elements and then put your name and today's date. Okay? And then you're going to take a snapshot of this report and upload it into Google Classroom, as I mentioned. Let me explain what you're going to do today. As you can probably figure out according from the title here, we're going to be looking at families of elements. In other words, elements that are in the same column on the periodic table. Remember, that's a family or group. And we're going to see if they do indeed react in similar manners. And here's how you're going to do that. Each of you will be given a plastic, what's called a chem plate, a plastic plate that looks like this, and it has 12 different circular wells in it. And then it's got a big one here, but you don't have to worry about that. All right? 1 through 12 different circular wells. In those wells, you're going to be mixing two chemicals, and you're going to be observing the chemical reaction. Okay? According to this diagram right here, below each of the circular wells, not on your chem plate, but on this diagram, you are looking at a proportion. So 11 to 1, 12 to 2, 9 to 3, 8 to 4, etc., all the way to 1 to 11. That ratio is telling you the ratio in which you are combining drops of each of the chemicals. So when it says 11 to 1, that means 11 drops of the first chemical to 1 drop of the second chemical. 10 drops of the first with 2 drops of the second. 9 and 3, 8 and 4, etc. Okay? All the way down to 1 to 11. That's 1 drop of the first and 11 of the second. You are going to be looking at how silver nitrate reacts with potassium chloride according to these ratios here. And then in a different chem plate, or a different student might do this one, we're also going to look at silver nitrate with potassium bromide. And then we'll look at silver nitrate with potassium iodide, silver nitrate with potassium sulfide. All 4 of these are going to be combined in these different ratios. Okay? Now, what I think we'll do is, instead of you having to do all 4 combinations, is we'll divide this up so that some students are doing number 1, some students are doing number 2, some students are doing number 3, some students are doing number 4. So in class, if I assign you to do combination 1, that's all you have to do. If I assign you to do combination 2, this is all you'd have to do. If I ask you to do combination number 3, then that is all you'd have to do. Okay, sorry about that. And then there's combination number 4 here. That's all you'd have to do. And then we'll share the results. Okay, we'll just share the results amongst the class. So what you will do is, you are first going to, on your lab report, I'd like you to draw this diagram right here. Okay. Now normally in a lab report you would have, you got your title, this is your title by the way. All right. Then we might have materials, and I'm not going to ask you to write the materials, you don't have to write that down, but I'm just letting you know, a list of materials, and then we would have also procedure. We have a procedure, step by step, what we're doing. I'm not going to ask you to write that down. We also probably would have a hypothesis or maybe a statement, if this, then that, or this is what we predict, something like that. And then we might have some data. Now, I do want you to write down some data, okay? I want you to write down some data. And what you're going to do is you're going to copy this table right down here on your data table. All right? So you're going to make this data chart right here, and you are going to copy this table, and then we're going to fill it in. Okay? After you have performed the experiment with the different chemicals. So if you want to pause the video right now and make this table, copy this table onto your lab report, you can do that. Okay? So right there you'll have the data table. Okay? Okay, now let's go back to again what you're going to do. If you are assigned silver nitrate and potassium chloride, then you are going to find the 2 small bottles that have each of those chemicals in them. They're small little dropper bottles. Find those, and you're going to, in your chem plate, on your plate, you're going to combine them in these ratios. So in well number 1, you're going to drop in 11 drops of silver nitrate in there, and just 1 drop of potassium chloride. Okay? And then we'll see what happens. And then continue with the same 2 chemicals, silver nitrate, potassium chloride. Put in 10 of the silver nitrate, 2 of the potassium chloride, and continue in these ratios all the way down. Notice there's not a ratio for well number 12. Okay? If you are assigned combination number 2, you do exactly the same thing, only with silver nitrate and potassium bromide. And then combination 3, you do the same thing with silver nitrate and potassium iodide. And if you have combination number 4, it's silver nitrate and potassium sulfide. Okay? Then what I'd like you to do is to record your observations, and all you're going to do on your piece of paper here, after you've kind of done that data, is you are going to write down some observations. Your observations are going to be which combination produced the best results. And how are you going to know this? Well, the best results, when you combine these 2 chemicals, there's going to be a cloudy precipitate. So which combination or which ratio, right, which ratio produced the best results? You're looking at which is most cloudy. It might be difficult to kind of figure that out at first, but which one is most cloudy based on your best observation? Okay, which is most cloudy? Answer that question. The other observation that I want you to make is after you have done your combination, let's say you did potassium chloride and silver chloride, you're going to tell me which proportion you think is the best, right here. And you're going to write in the ratio that you think is the best. Okay? If it's not perfect, that's okay. We'll figure it out. But you're going to tell me which of these combinations do you think is the best out of all of them, which produced the most cloudy precipitate. And then, if you've done yours, let's say you were assigned number 1, you are going to have to get the information from anybody that did number 2, and anybody that did number 3, and anybody that did number 4. Okay, just share your data in class. You can just kind of get everybody's attention or get somebody's attention next to you, find out who did the other ones, and write down what proportions they think gave you the best results, which gave you the most cloudy precipitate. Okay? Now, what I'd like to look at here is what is happening with these different precipitates. Okay? But we'll do that in a second. Once you have all of this data, now by data I mean these proportions, we're going to fill in the rest of this in a little bit, but once you have these proportions, then what I'd like you to do is look at those proportions and try to determine which of them are reacting in a similar manner. And then answer this question in your lab report. Which of the elements appear to be in the same family? And try to do it without cheating and looking at the periodic table. Just look at your results. Which one do you think is going to give you similar results by looking at the proportions here that produce the best cloudy precipitate and the same type of cloudy precipitate? Okay? Now you're going to tell me why. Why do you think that those are in the same family? What did you observe? What did you observe that gave you the inclination that they're in the same family? Okay? And then answer this question: what family of elements is illustrated in this activity? In other words, now you can look at a periodic table and tell me if you think certain ones are all in the same family, which family is that? Okay? All right. What I'd like you to do at this point is go ahead and perform the experiment. Grab your chemicals and try to figure out which proportion for your combination, for your two chemicals, is going to give you the best results. So pause the video here, and then once you've done that and you've collected these proportions from your experiment or from your classmates' experiments, then come back to this video and we'll go over the results and talk about the formulas as well as the chemical reactions that are taking place. Okay, you're coming back to this video. You should have already completed the experiment by combining your two chemicals in the necessary ratios and writing down your observations and then making a conclusion about which proportion do you think, which ratio do you think is the best, which gave you the best results. Okay? Now, I'm going to share with you what your potential results could have been. If you didn't get exactly these values, it's okay. But here's close to what you should have gotten. This is what you should have gotten close to these results. Okay? If you did experiment number 1, combination number 1, the best result was when you had about 6 drops of silver nitrate along with 6 drops of potassium chloride. What you saw, the precipitate that was formed, was a milky white precipitate. Okay, milky white solid. When you mix the two together, it became cloudy, and that was a solid that was being formed. Okay, so what is this proportion? Well, 6 drops of one and 6 drops of the other is a 1-to-1 ratio. That's a 1-to-1 ratio. I'd rather have ratio here instead of proportion. Okay. Now for experiment number 2, the second combination, if you did this one or if you got it from your classmate, this also was about a 1-to-1. Now you might have gotten 7-to-5, okay, or maybe 5-to-7, but still that's close to 1-to-1. That's pretty close to 1-to-1. And you got a very similar looking precipitate. It also was a milky white precipitate or a solid. So this is about a 1-to-1 ratio as well. Close. All right. If you did combination number 3, silver nitrate and potassium iodide, this also would be about a 6-to-6, or again, maybe you got 7-to-5 or 5-to-7 if you thought those were the best results. All of these are pretty close. All of these are pretty close to assume, we could assume it's about a 1-to-1 ratio. About equal amounts of both gave you the best results. Gave you that nice milky white solid. Okay? So you should have noticed, one, that these first 3 combinations all gave you a milky white solid, and all of them combined to give you the most milky white solid, the most precipitate, all of them combined in about a 1-to-1 ratio. Okay? Now the silver nitrate, that's silver nitrate with the potassium sulfide is a little bit different. That should have combined in a different ratio, about an 8-to-3 ratio or 8-to-4 ratio. Or I should say 8-to-4 because they're total of 12 drops in all of these. So 8-to-4 ratio. So that is different. That's definitely different. And also you should have noticed that it produced a black precipitate, not a milky white. It's a black solid that is formed. So very different. So this ratio is closer to 2-to-1 to 1, closer to 2 to 1 ratio. So what does that mean? Just from the color of the precipitate and the ratio that is the best product, you should notice that the first 3 here are all very similar. That means what? Well, silver nitrate is combined with potassium chloride. Notice the chloride here. Silver nitrate is combined with potassium bromide. Silver nitrate is combined with potassium iodide. So what do you have in each of these? You have chlorine, that's Cl. You have bromine, Br. And you have iodine, I. That's the only thing that's different in the first 3 combinations. So that must mean that chlorine, bromine, and iodine all react similarly. What does that mean? It puts them in the same family on the periodic table. Sulfide, that is from sulfur. Sulfur is acting a little bit differently. It forms a different color precipitate, and it reacts in a different combination, a different ratio. So it's going to be in a different family. So that helps you answer these questions right here. Which elements appear to be in the same family? Chlorine, bromine, and iodine. Why? For the why, you're going to tell me that they had similar results as far as the color of the precipitate and similar ratio in which they reacted. Okay? And what family of elements is this? The family here is group 17 on the periodic table, which are the halogens. All of these, chlorine, bromine, and iodine, are all halogens. They're in the same family, group 17. Okay? Now, we're going to take this one step further. So on your report, you should have filled in so far this much of the table, and you've answered the question that I gave you earlier. Okay? Basically, we're looking at what combination gave you the best results by answering these questions here. Okay? You've answered these 3 questions, wrote down your observations. Now, we're going to take this one step further, because we're at a point in chemistry where we can talk about these reactions and actually write down the chemical reactions that take place, the chemical equation. Okay? So for this last column right here, we need to figure out what is the formula of the solid. What is the formula of the solid that is being formed? So for each of these 4 reactions, I am going to share with you, we're going to do this together, what the reactions are. So the first one was silver. I'm going to write it in words and then we're going to translate it. Silver nitrate, and it was potassium chloride. All of these are occurring in aqueous solutions. Okay, the dropper bottles that you have, the smaller bottles, they're all aqueous solutions. Those are water solutions that have a solid dissolved in them. Now, let's translate each of these. Silver nitrate. Well, silver nitrate, silver wants to form a +1 ion. These are all ionic compounds. Metal silver with nitrate. Nitrate is a polyatomic ion, so if you looked on your periodic table, you would see that nitrate forms a NO3 with a -1 charge. So how many of each of these? We need 1 silver for every 1 nitrate. That's the formula for silver nitrate. Potassium chloride. Potassium is a metal, forms a +1 ion. Chlorine is a nonmetal in the group 17, forms a -1 ion. So that's 1 of each, potassium chlorine, just like that. Now, what's going to happen here? Hopefully you realize this is going to be a double displacement reaction. Do you see here? Metal, nonmetal group, metal, nonmetal. These are both aqueous, so put AQ there. And there's going to be a double displacement. The metals are going to switch places and see what happens, because now we're going to put these 2 together in that well, and now they can switch places if they want to. So potentially what could we have? Well, we could have the potassium coming with the nitrate. So that would be the positive potassium coming with the -1 nitrate, and that would form KNO3, just one of each of those. But the potassium nitrate stays dissolved in water. It's not going to be becoming a solid. Potassium nitrate is dissolvable in water, it's soluble in water. So we just continue to put AQ there. The other combination is the silver with the chloride. Silver is a +1, chlorine is a -1. In this case, you're going to form AgCl. Now, silver chloride is not soluble in water. When the silver and the chlorine get together, they actually form something that does not dissolve well in water. That's why you see it. That's why it becomes a solid. So we're going to put S here for solid. So silver chloride is the milky white precipitate that you are viewing. And we're going to put its name right here in our table. AgCl. Okay? Is this reaction balanced? Yep. 1 Ag on both sides, NO3 on both sides, potassium on both sides, and chlorine on both sides. Okay? Let's do the second one. This was silver nitrate. Well, I already know the formula for silver nitrate. And this time it's potassium bromide. Well, potassium bromide, I'll put it up here. Potassium again is a +1, and bromine forms a -1. So they're going to come together in a 1-to-1 ratio. So that's going to be just KBr. And like above, they're going to switch places. They're aqueous solutions, and they're just switch places. So the potassium with the nitrate, we already did that. That's dissolvable. That's soluble. This is still going to be AQ. But the silver with the bromide is going to form, silver is a +1, bromide ions a -1, just one of each of those. This, again, is not soluble. So this is going to be a solid, and we can put it in our table. Okay? Let's do the third one. Again, silver nitrate and potassium iodide. Iodine is a -1 ion that it likes to form. Potassium is a +1, so just one of each of those. And just like the first two, we're going to form potassium nitrate, which is soluble, and silver iodide. That's the formula for silver iodide. +1 silver, -1 iodide, and this is not very soluble. That's the solid that you see. Silver iodide. Okay, last one. This is potassium nitrate, silver nitrate again. And this time we're going to have potassium sulfide. Well, that's going to be a little bit different. Why? Because potassium is a +1. Sulfur is in group 16 with oxygen. That group likes to form 2 negative ions, a -2 charge on the ion. So I'm going to need 2 potassium for every 1 sulfide ion to make a neutral compound. So the formula here is K2S, because it's a sulfur from a different family. Now, when these switch places, silver and potassium, the potassium's still going to go with the nitrate and form potassium nitrate. And this is aqueous. The silver is going to go with the sulfur, but silver is a +1 and sulfur is a -2. So you're going to need 2 silver for every 1 sulfur. 2 silver for every 1 sulfur. And this is not soluble, so that is the precipitate that you're going to see. This is going to be silver sulfide, Ag2S. Ag2S. Now, we have to balance this one because we don't have the same number of silvers on both sides. You have 1 over here on the left, 2 on the right. So I got to put a 2 in front of that. That doubles the number of nitrates. So I got to double the number of nitrates here. That doubled the number of potassiums, which we do have 2 on the other side, and now it is balanced. All of these have been correctly written using the double displacement method, forming the correct products, and then correctly balancing them. Okay? So all of these, the first 3, reacted in a similar manner because they're all in the same family. They all form similar precipitates, and they all form they have the same ions that are formed, all with -1. Okay? Now remember, I'm going to add another question here, and I want you to respond to this. Okay, so this is your, I don't know, it's your 4th question maybe on the observation. What is it about the electron configuration that allows these halogens to react in a similar manner? Okay? Describe the electron configuration of elements in group 17. Okay? This is like your bonus question here, okay? This is great. That's your bonus question there. Not that you're going to get extra points, but it's just taking you a little step further. It's an extension question. Describe the electron configuration of elements in group 17. What is it about their electron configuration that makes them behave in a similar manner? And really, you don't have to look at the entire electron configuration. Just look at the dot diagram, which shows the outer valence electrons. What is it about chlorine, bromine, and iodine? What is it about their outer valence electrons that makes them react in a similar manner? What if you were to draw the dot diagram for each of these and then compare it to sulfur? How is it different? So describe the electron configuration, or I could just say, look at the valence electrons. What is it that's similar and that causes them to react in a similar manner? Okay? That's your 4th question there. Okay, and then your last question here is going to ask you to do a little bit of research, or looking back at a previous chapter, and that is number 5. I want you to state the periodic law. This is crucial here, in your own words. Of course, you can look back and find the periodic law, but I want you to state it using your own vocabulary so that I can see that you understand what it is saying. Okay? All right, so here's what you have. You should have a title. You got your name, your date. We're not worried about materials, procedure, and hypothesis right now. You have the data table that we filled in together, and then you basically are answering about 4 or 5 questions. I don't remember exactly how many I have there. 4 or 5 questions, I guess there's 5, that we're going to call your observations. And from those observations, we were able to conclude which combination had the best results, and we also answered, from those observations, we were able to conclude which elements appear to be in the same family and why, and then what family is that. And then we added on a little bit there in that I ask you to describe the valence electrons of these elements in the same group as compared to sulfur, what makes them similar, and state the periodic law. State the periodic law. Okay? In addition, you should have on your lab report, you should have these reactions written. Each of these reactions are showing you what's taking place for each of the combinations that we did in today's experiment. Okay? Now, if you've got questions, just raise your hand. I'll come around or get my attention, and I'll be happy to answer your questions as you're doing this experiment. When you're done, also I want you to just raise your hand and let me know you're done so I can maybe just take a quick look at it before you submit it. And if you have my approval or you think it's good to go, you can submit this, take a picture of it, and upload it into the Google Classroom for submission, and then I'll check it and give you credit. Okay? All right, great. Let's keep up the good work. Thanks.